Myself, Dr. Naresh Kumar, Associate Professor, Department of Mathematics, Institute of Aeronautical Engineering, Dundigal, Hyderabad. Today, I am going to start Module 5 of a title of the syllabus, Differential Equation and Vector Calculus. So now in Module 5, I want to going to discuss about a topic which is very most important and also very easy, known as a basic concept of line integral. I want to discuss in this lecture in detail what is line integral, what is concept of line integral. So in this video I am discussing in detail about line integral. Basic concept of line integral. Definition of a line integral. What is definition of a line integral? How we can define a line integral? So any integral which is to be evaluated along a curve. Any integral which is to be evaluated along a curve is called a line integral. Second one is surface integral. That is we will discuss in next video. What is surface integral? So definition of surface integral, any integral which is to be evaluated along any surface is called a surface integral. And third one is volume integral. Any integral which is to be evaluated along any three-dimensional body along volume is called a volume integral. So in each topic we apply some theorem to find the integral. Now basic concept of line integral we will discuss here, and I am going to discuss basic concept of line integral. And we proved here one formula which is applied to find a value of line integral. So here I am taking a curve. This is a curve which is I am taking here. So this is curve here. This is curve. Okay. This is given any curve. And we want to integrate. We find the integral along this curve. So starting point of the curve is A. A is starting point. So the position of the point is P0. Next one is P1. This is P1. Next position. There are several points on the curve from the point A to B. We have taken several points. And the position of the points are different. If position change, then the value of the point is change in coordinate system. So we want to calculate the value of line integral in three-dimensional system. So this is basically three-dimensional system. This is origin O. This is Z axis. This is X axis. This is X axis. And this is Y axis. Okay. Along this axis I cap. Along this axis J cap. Along this axis K cap. So there are several points. This is any point is. This is Pi1 minus 1. Pi minus 1 point. and this is general point is P, X, Y, Z. This is general coordinates. This is variable coordinates. All points are constant, but this is variable point, P, X, Y, Z. This is mobile point, movable point. The value of point P is not fixed. The value of point P is variable, that is changeable at every moment. P may be at any place from A to B. Then next point is this is Pi. Next stage is Pn minus 1. And next last point is B, that is Pn. So the curve in three-dimensional geometry from point A to B, I have taken several points on the curve. First point P0, P1, P2, P3 and ... Pi minus 1. And in middle this we have taken point P, X, comma, Y. This is not constant point. Other all points are constant. And Pi, Pn minus 1 and last is Pn. Pn is B and P0 is A. So here A equal to P0. We have taken A equal to P0, comma, P1, comma, P2, P3, Pn minus 1 and last is Pn. Pn equal to B here. And let R naught vector, R1 vector, R3 vector, Rn minus 1 vector and Rn vector. What is this R naught vector, R1 vector? R naught vector is the value of the function at point P0. R1 vector is the value of the function at point P1. R3 vector is the value of the function at the point P3. Similarly, R vector n minus 1 is the value of the function at point Pn minus 1. And Rn vector is the value of the function given at Pn point. So this point here Pn value of the function, here function is vector Rn. Here value of the function vector is Rn vector. Here value of the function is Rn minus 1 vector. Okay. And here is P0, this is R naught vector. P1, this is R1 vector. Okay. If the position is P0 on the curve at point A, then the value of the function at point A is R naught vector. And P1 is the position of a point on the curve. Then the value of the function at point P1 is R1 vector. Similarly, point P2 on the curve at point P2, the value of the function, vector point function, is known as a vector R2. Similarly, point is Pn minus 1 on the curve, then the value of the function at point Pn minus 1 is vector Rn minus 1. At last, Pn be the last point on the curve, that is at V. So the function value of the vector point function on point V is known as a vector Rn vector. So here we define these are the functions at P0, P1, P2 and Pn minus 1, Pn respectively. Okay. Let Qi be the position of the vector of these points. Let Qi be the any point on the arc Pi minus 1 and Pi. This is the difference between these 2 points, pi minus 1 and pi. Then limit of the sum, we write here line integral. We write formula summation vector point function qi dot del ri vector. Okay, where I equal to 1, 2, 3 and n. I is 1, I is 2, I is 3 and so on. Where delta ri vector equal to ri vector minus ri minus 1 vector. Ri vector is the value of the function at pi point and ri minus 1 vector is the value of the function at pi minus 1. So difference between pi and pi minus 1, difference between the value of the functions at pi and pi minus 1, that is vector ri minus vector ri minus 1. So that is difference is delta ri vector. This is the difference between points, position, and this is the difference between function. So now when n tends to infinity, I here limit from I equal to 1 to n. There are n partition from A to B. We are taking n coordinates, n points from A to B. When we are taking infinite points on between A to B, that distance between 2 points is very, very less. So I am saying here limit, condition about limit, if n tends to infinity, n is the number of the points between A to B. When number of the points increase, then value between two different points is decrease. Okay. So n tends to infinity as well as delta ri tends to 0. Difference between 2 points, difference of the distance between 2 points is decrease and very, very less when the number of the points between A and B increase. So here if we are taking n tends to infinity means number of the coordinates are infinity between A to B, then delta ri, mod of delta ri is 0. Mod delta ri means value between 2 points. After taking mod, we find out the modulus. Modulus means distance, value between 2 points, that is goes to 0. If it is exists, it's called a line integral of vector f along curve denoted by along curve C denoted by. So line integral equal to summation I equal to 1 to n vector function qi into delta ri. This result convert in integration. Summation, any summation convert in integration. And C is curve. A and B are 2 points on the curve. Then this convert in any vector point function f and delta ri convert in dr vector. After applying limit. Limit means delta I tends to 0. Or we can say here integral C f vector function dr over dt. We divide here dt and multiply dt here. So dr over dt into dt. This is the formula for integral. Then r vector is some function of t. Then integrating with respect to t. So here we basically be using the formula line integral here. Summation I equal to 1 to n vector function qi dot del ri vector equal to C. Basic formula is this here. This is the basic formula. Vector function is given and position vector between 2 points are given. Means this is force. Force applied on any body and body displaced from one point to another point. Then difference between 2 points is dr vector. So dr vector means this is the displacement in vector form, and f vector means this is the force applied on the body. So after taking dot product, vector f and dr is displacement between 2 points. But there are several points from A to B. So that is the addition work done by the force between all points. That is the addition. Addition convert in integral from A to B. So this is the integral C vector function dot dr, or we can say vector function dr over dt into dt. Dr over dt means r is the vector, r is the function of t. R has three variables x, y, z, and x is the function of t, y is also function of t, and z is also function of t. Okay, so this is two formula, basically two formula we are using here. Formula 1 integration c and f vector dot dr vector. This is formula. Next formula is integration c f vector dot dr over dt and into dt. So these two formula basically we apply in our question. First formula is if x, y, z are not function of t. The second formula is if x, y, z are parametric form, x is some function of t, y is some function of t, and z is some function of t, then dr over dt into dt are differentiate with respect to t. So here we dt divide and dt multiply. Now here, after proving this formula, we apply two cases here. So what is case 1? Case 1 is if vector point function, this is force x, y, z, value of this in 3-dimensional f1i, f2j, f3k. This is the force applied on the body represented by this f vector. This is force, 3-dimensional force which is applied on the body, and this is vector r, general vector xi plus yj plus zk. Now change in vector r, change in position of vector r, that is known as a dr. Dr means difference between two positions of the point, and with the help of this force we displace the body from one point to another point. So the difference between two points is dr, and dr represented by dxi plus dyj plus dzk. Then formula for the line integral convert into the following form. So here integral c f dot dr, basically this formula is in vector form. This is in vector form. Now we want to convert this in scalar form. So here integral c, this is the vector point function force, and this is the displacement. So here dot product. I am taking here dot product. So we are taking always dot product between I to I dot I1, j dot j1, k dot k1. Other dot product are 0 I dot j, I dot k. Next j dot I, j dot k. Next k dot I, k dot j. All 0. So we have here only 3 terms only. Then we get here formula. This integral c f dot dr equal to f1i, f2j, f3k, dxi and dyj, dzk. Now after taking dot product, we get this result here. Integration c f1 dx, f2 dy, this is not j here, and f3k. This is equation 2. This formula is used when case 1 when a force apply on the body and body change the position between one point to another point. So the change of position is dr. Dr is the displacement covered by the body after applying force F. Then we get line integral C vector F dot dr. And basically this is in scalar form, not in vector form. This formula is in vector form. Now case 2, apply case 2. In this case, if the parametric equations of the curve C are given here, if value of the variable x, y, z are in parametric form. Parametric form means x and y and z are some function of t. So here x equal to xt, y equal to yt and z equal to zt. And at where t is point, t equal to t1 at point A and t equal to t2 at point B. Then our formula will be changed. Then we apply next formula, integral C vector point function, and this is the difference between the position f dot dr equal to C f1 dx dt into dt plus f2 dy upon dt into dt plus f3 dz upon dt into dt. So here apply bracket. Okay. In last integral here, integral C vector f dot dr vector, and this integral C here f1 dx plus f2 dy plus f3 dz. This is formula. In case 1, we apply this formula. If x, y, z are the parametric form, then we apply here integral C f1 here dx divided by dx over dt and plus f2 dy over dt and plus f3 dy over dt dz over dt and multiply by dt. So this is second formula. So here second formula is integral C f dot dr equal to integration t1 and t2. T1 is starting point, t2 is last point. This is the value of t. So f1 dx over dt, f2 dy over dt, f3 dz over dt. Into dt, this is equation 4. So basically we have used only two formula. This is formula 2 and this formula is 1. This is case first and that is case is second. This is the discussion about line integral in detail. How we can find formula for line integral. So we have proved here about the formula. Now we are using these formulae to solve the problem of line integral. So we are going to discussing about some problem based on line integral. So problem 1 based on line integral. Suppose this is vector point function. This is force. Vector point function means force. Force, this is vector. Any force is a vector quantity already. So vector force equal to xqy plus yj plus zk. Three-dimensional vector point function that is represented by force applied on the body is the force field. Find the work done by the force F along the line from point this to this. Along the line from point this to this. First of all, we want to find here equation of line. What is line equation? And the particle, a body, move from point A to B. So here solution. A body a body is moving from point 1, 2, 3 to 3, 5, 7. Suppose this is point A, 1, 2, 3, and this is point B, 3, 5, 7. So this is line. Okay. So we want to find out the equation of line. Now, equation of line. Equation of line. We are applying in three-dimensional geometry, 3D. Here we apply three-dimensional geometry. Three-dimensional geometry. So now equation of line. What is equation of line? Equation of line is x minus alpha upon a, y minus beta upon b, and z minus gamma upon c, where a, b, c are ratios, direction ratios. Direction ratios. A, B, C are direction ratios. So is A, basically A equal to x2 minus x1, V equal to y2 minus y1, and C equal to z2 minus z1. And alpha, A is alpha. A point is alpha, beta and gamma. What A is here? 1, 2, 3. So alpha is 1, beta is 2, gamma is 3. So now value of A is y2 minus y1, 3 minus 1 equal to 2. And B is equal to 5 minus 2 equal to 3. And Z equal to Z2 minus Z1. So this is 7 minus 3. This is 4. So now A is 2, B is 3, C is 4. Difference between these points. So here ABC, these are ratios, direction ratios. Direction ratios, and this is alpha, beta, gamma. This is A point, value of point A, value of point A here. So now x minus alpha, x minus 1 upon A is 2, x minus alpha upon A, x minus alpha upon A, y minus beta upon B, and z minus gamma upon C, where alpha is 1, beta is 2, gamma is 3, A is 2, B is 3, and C is 4. Now x minus alpha, x minus 1 upon A, 2, y minus beta, beta means y minus beta 2 upon C3, and z minus gamma, gamma upon C4, this is equal to t. T is some constant here. So now x minus 1 upon 2 equal to t. So x equal to here 2t plus 1. This result is 2t plus 1. And next is y minus beta, y minus 2 upon 3 is also equal to t. So y equal to 3t plus 2. This is y. And z equal to z minus gamma upon 4 equal to t. So this result is z equal to 4t plus Gamma is here 3. Z minus 3. So 4t plus 3. Now position is pxyz. So the value of p is x 2t plus 1 and 3t plus 2 and 4t plus 3. This is basic position. Okay. Now here this is t. This x cube, y and z. So here dot product. Taking dot product between the points. So now integration c vector f dot dr. This is the formula. So here formula is f1. F1 is x q y plus y j and plus z k and into dxi plus dyj and dzk. Now this equal to here integration c x cube dx plus y dy and plus z dz. Okay. So now x cube dx, y cube dy and z cube z dz. So integration of this here, putting x4 y4 plus y square y2 plus z square y2. So now putting here value of 4 x4 plus 2y square and plus 2z square. So now this equal to work done. Integration this here putting x equal to t here, y equal to t and z equal to t. X some value of t and y is some value of t and z is value of t. So now putting here, but t is here 1. Work done is here x to the power 4 and plus 2 y square plus z square upon 4. Okay. Now putting the value of x here, x is t is 1 here, t is 1. Putting t equal to 0 and t equal to here 1. T equal to 0 and 1 here. So now putting here t equal to 0 and 1. After putting value here t and 0, y and t, then we get result here. So here 0 to 1. Putting value of x. What is x here? 2t plus 1. So here 2t plus 1 whole 4, 1 by 4 is out. 2t plus 1 plus 2, 2t plus y. Y is 3t plus 2. 3t plus 2 का whole square and plus 2, 3t, 4t plus 3. 4t plus 3 का whole square this. Now apply 0 to 1 limit. T equal to putting minimum 0, maximum 1. So upper limit minus lower limit. 1 is here. 1 means here is 3. 3 to the power 4 minus 0 means 1 plus 2 here, putting 1, 5 square and minus 0, 2 का square plus putting 2 here, 1 7 का square minus 3 का square. So now this 1 by 4, here 3 is 9, 3 is 9, 81 minus 1 plus 2 here 25 minus 4 plus 2 here 49 minus 9 here. So now final answer is 1 by 480 plus 2 into 20 and plus 2 into 40. So this equal to work done is equal to 80, 1 by 4 here, 80 plus 40 and plus is 80. So here 1 by 4 here 200. So 520. 20 Newton and meter. Okay, this is the answer. Now next, second problem based on line integral. We want to discuss problem 2 based on line integral. Find the total work done by a force capital F, x square plus y square into y minus yj in moving a point from 0, 0 to AB along the rectangle bounded by the lines x equal to 0, x equal to a, y equal to 0, y equal to b. So what is the total work done? I want to discuss about the total work done by the given force and moving a point from point 0, 0 to a comma b. This is two-dimensional movement in two-dimensional. So in our force is only two vectors I and jk. So here solution. First of all, making here this x-axis and this y-axis origin. There is not third axis, z-axis. So here point A, this is A point, position of this A comma 0. This is origin here. So this distance is A. This is known as A, x equal to A. Now this coordinate this here. So this is point B. This is y equal to B. Y equal to B. This is y equal to B. This is x equal to A, not y equal to B is this. Y equal to here 0. Y equal to 0 on x-axis. Here is x equal to A. And here is x equal to 0. Now this is y equal to B, A, B. So coordinate of this A comma B. Okay. Particle moving from O to A, this is vector, O to A and A to B. A to B. So now finding value of the work done by the force from point O00 to B A comma V. So now integral C vector F and dot dr. This equal to integration C. Here breaking C in OA vector F and dot dr plus A to B vector F and dot dr. So this is basic formula we are using here. OA, O2A and A to B. So now integration C vector F dot dr. This equal to I1 plus I2. I1 is first integral this is I1, and second integral this is I2. I1 and I2. Now find out the value of I1. I1 is integration OA and F vector and dot dr vector. This is along x-axis. Along x-axis means y equal to 0. Y equal to 0 means dy is 0. So these two values putting here. So now final is I1 is equal to integration OA F is x square plus y square into y minus what is value of the function f? F is given in our question minus by j. Minus by j this vector and dot dr. Dr means dxi and plus dyj. Now taking dot product, integration OA, here I to I, x square plus y square into dx and minus y into dy. Okay. What along x-axis? Along x-axis or along OA? OA, we get following results. Following result means y equal to a, y equal to 0, y equal to 0 here, and dy equal to 0. Now putting in equation 1, putting in equation 1, integration OA y equal to 0, so x square dx, and y is 0, so only this result, y is 0, dy 0, so we get only this result is x cube by 3. Now limit is 0 to a, OA means 0 to a, OA means 0 to a. So this result a cube by 3, 0 to a. So this I1 is equal to a cube by 3. This is value of the first integral, equation 2. Now finding value of I2, second integral. So I2 is equal to integration AB, and here x square plus y square into dx minus y dy. This is third integral. Along AB, what is along AB is? In diagram, along AB is x equal to a. Equation of this line, x equal to a. X equal to a means dx equal to 0, and limit from a to b. Limit from here is value of x is by, value of y is 0, and here value of y is b, 0 to b, because this integral along y axis. So putting these values putting in 3. Then I2 is equal to second integral integration AB x is 0 dx 0. So this total result 0. X 0 and dx 0. So here is minus y dy. This equal to integration. Y is 0 here and here is v. So here minus sign y dy. So this equal to minus y square y2. Putting value 0 to v. So here is minus upper limit b square y2. This is I2. Now adding I1 plus I2. Adding I1 plus I2. This is total work done. Total work done. I1 is, what is I1? A cube by 3 and plus minus b square by 2. So this result is, this is answer. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.